All right, we're going to jump into lesson 411 here, guys. And in this lesson, we're going to do some more work with inequalities. And we're going to not only write inequalities, but we're going to learn to graph them to represent real-world situations as well. All right, so we're going to look at a couple of different scenarios here. In the first one, the boat can hold a maximum of 10 customers to go out and see these alligators in the wild. The number of people in the boat can vary each trip. So my variable would be the number of people in the boat. So let's just call it X equals number of people in the boat. Or the customers. And explain which numbers do not belong in the fraction or in the solution set. In this solution set, remember the set is our all the answers that would make this true. And what I know, we can't have a fraction or a decimal of people, so no fractions. We also can't have 0 customers because the boat wouldn't go out. Okay, and we can't have negative numbers. And all these different things, these constraints that don't belong can vary in every situation depending on what we're talking about. But in this case, no fractions. You can't have 0 customers, and you can't have negative numbers because we can't have negative people in the boat. So record an inequality. The main point here, we'll represent this with an inequality. So X has to be less than or equal to 10 customers. You can have exactly 10 customers. And X also, according to what doesn't belong, X must be a counting number. Okay, you can't say whole number because a whole number includes 0, so it has to be a counting number. Okay, so to graph this solution set, I put dots on every answer that makes this true. Again, I can't have 0 customers or the boat won't go out, but I can have 1. So I just fill in 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, because I can have a 10. It says X is less than or equal to 10, so I can have exactly 10. I do not fill these in and make the line and connect them, because then that would include all the fractions and decimals between there, which we know those don't work for this situation. They have to be counting numbers. So there's one situation and what the graph would look like to represent this. I'm going to erase this now, so pause the video if you need to, if you're watching at home, and make sure you get these written down. Okay? And then we'll look at one more example. All right, on the next example here, we're talking about the boat operates when the air temperature is at least 55 degrees and the temperature varies. So to find a variable, what changes and can vary here is the temperature. So I'm just going to put T for temperature is what varies. And explain which numbers do not belong in this solution set. Got to start thinking fractions and decimals and those things would work here because you can have partial degrees. So it's not like the question up above. But which numbers probably don't belong in this solution set? You got to be thinking of this situation. When it gets too hot, people won't come out. So maybe we could say when temperatures are 100 degrees Fahrenheit or greater, those would not be in the solution set to make this true, because eventually it gets too hot, people won't come out. So this company probably wouldn't go out and take tours because they know people don't come out and they don't make money. So if it gets 100 degrees or greater, in this case, and again, we could word this differently to include 100 degrees or not include 100 degrees if they go out. It just depends how we word it, and that's our choice when we put on this constraint here. Okay, so to record inequality number models, we know the inequalities that the temperature has to be greater than or equal to, because it's at least 55 degrees Fahrenheit. But at the same time, if temperatures are 100 or above, they don't go out. So my temperature must be at the same time less than 100 degrees Fahrenheit. Okay, we didn't say less than or equal to, okay, because temperatures are 100 degrees, they do not go. So we want the temperature, it has to be less than 100. If it's exactly 100 or more, they don't go out. So to make this true, when these boats go out, it has to be greater than or equal to 55 degrees Fahrenheit, but less than 100. So to graph this solution set, it's going to look a little different than the one up above. Okay, so we're going to start. It has to be 55 degrees. So it looks like 60, 70, 80, 90, 100. They're going by tens here. So 55 would be right here in the middle. Okay, and it has to be greater than or equal to 55. So I'm going to put it right in the middle. And notice I filled in the dot because it can include that temperature of 55 degrees. Okay, but then 100, we said it has to be less than. It cannot be exactly 100. So we represent that with an open circle, meaning we do not include 100. It wouldn't go out. Okay, but anything less than 100, now I'm going to shade this in. So anything between 55 exactly, all the way to, and again, it's not 100, but it would be everything less than 100. So it could be like 99.5 or 99.7. We know decimals are infinite, or fractions in there. So everything in between there, this boat would operate when the temperature is in between that range. All right, so these are a couple of examples of real life situations where you'll see inequalities in the real world.